Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration of trigonometric functions. This is part 12, and I encourage you to check out our previous videos. That's integration from part 1 to part 11. Also, subscribe so that you don't miss out on our future uploads. Great. Let's dive into today's business. It is important to note that integration of sine f of x dx is equal to minus 1 over f prime of x times cosine of f of x plus c, which is the integration constant. Remember, when we differentiate cosine, we get a negative sine x. That is to say, if then we reverse the whole process, integrating sine x would give us a negative cos x. And in this case, if we have an f of x, which is not x, we would have the f prime of x being divided times the cosine of f of x plus the c. Then it means that for the integration of sine ax plus b, we are going to have a minus 1 over a, because recall, f of x in this case is ax plus b. The derivative, or f prime of x, is just a. So we would have minus 1 over a cosine of ax plus b plus c, the constant of integration. And take note, the constants a, b, and c are all real numbers. Let's move on. Let's look at the integration of cosine f of x dx. The answer here would be a positive 1 over f prime of x times sine of f of x plus c. Then it means that if we are going to find the integration of cosine ax plus b dx, our f of x is ax plus b, f prime of x is just a, times sine of ax plus b plus c. We are going to label this as formula 2. Moving on, in addition, if we have sec squared of f of x dx, we are going to have 1 over prime f of x times the tan of f of x plus c. Then the integration of sec squared of ax plus b dx is going to be 1 over a times tan ax plus b plus c. This one will be formula 3. I'm labeling this formula. Why? Because we're going to refer back to them from time to time. And take note, a, b, and c are all real numbers. Let's take a look at example 1. Evaluate the integral from 0 to 1 over 6 pi of cosine of 4x dx. In this case, to get the solution, we identify the f of x, and in this case, our f of x is equal to 4x, because that is what is inside the cosine function. Then, if we go on to differentiate to find f prime of x, we are going to get a 4, meaning that using formula 2, if we integrate, we are going to get the integration from 0 to 1 over 6 pi of cosine of 4x dx being equal to 1 over 4, because that is our a, or our prime f, times sine 4x, and keeping the limits from 0 to 1 over 6 pi. Then recall from our previous videos where we covered definite integrals. And I encourage you to check these ones out, because they are going to be useful if you haven't heard of definite integrals or have no idea of how to go about such kind of integration with limits. So substituting, recall we start with the upper limit. So we are going to have 1 over 4 times sine 4 pi over 6 minus, when we substitute for the lower limit, which is a 0, and recall, sine of 0 is 0, so we are just subtracting a 0. Now, simplifying this further, we are going to have 1 over 4 times root 3 over 2. Take note, we are preserving this as exact as possible because we do not want to lose the accuracy of the answer. It is advisable to keep our answers in this format unless specified to the degree in which the question would ask you to leave the answer in. Now, simplifying that, we are going to get root 3 over 8 as our final answer. Great. Let's move on to example 2. So with example 2, we have the diagram over here, or the graph. So in this graph, we see that it passes through the origin and has a maximum point M before it goes on to intersect with the x-axis on pi. The diagram shows part of the curve y is equals to 3 sine 2x plus 6 sine x and its maximum point M. Find the exact area of the shaded region. So before we continue, we already know that we are expected to come up with the exact value of the area. 1. 2. We know from differentiation that we can get the maximum or the minimum point through differentiation. And in that case, we are saying that we are going to differentiate our y, and when we get our y, we set it to 0. And from there, we get the values of x that would give us the point at which the graph hits its maximum. Great then. So dy dx would be 6 cosine of 2x plus 6 cosine of x is equals to 0. So with that, we also know from the identity of half angle, where we have cos 2x is equal to 2 times cosine squared of x minus 1. And in that case, we are going to have our dy dx being equal to, we substitute where we had cos 2x with what we have as the identity. So this is its equivalence, which is 2 cos squared x minus 1. Then we have that. Then we equate it to 0. We move on to simplify what we have, so that we have 12 cos squared x minus 6 plus 6 cos x is equals to 0. With that, simplifying, we would have 2 cos squared x plus cos x minus 1 is equals to 0. And recall, from our quadratic factorization video, and I encourage you to check it out because it's helpful and it simplifies our work. Check it out, quadratic factorization video. So we are going to proceed with what we have. Now, to simplify our work, we are going to set z be equal to cos x. Now, if z is equal to cos x, we are going to substitute into the equation that we had that had cos x terms. In this case, we're going to have 2 times z squared plus z minus 1 is equals to 0. And according to the quadratic factorization video, we are going to have this stage. And moving forward, we have that. And then in the end, we have 2z minus 1 times z plus 1. And we set each of these into 0. So because it means either that first part is 0 or the second part is 0. So we solve for z. In solving for z, in the first part, we are going to get z is equals to 1 over 2, or in the second part, z is equal to minus 1. And recall, z is equal to cosine x. Now, from the graph, remember the coordinate, x coordinate that is, should lie between 0 and pi. That means that our cos of x should lie within 0 and pi. The value of x, when substituted, should give us something that lies between that. So now, we are going to abandon this cos x is equal to minus 1 because the values of x that we get are out of this range for minus 1. So we abandon that to only consider the first part, which had z is equal to 1 over 2. That is the same as saying cosine of x is equal to 1 over 2. Now with that, we are going to solve for x. And solving for x, we get pi over 3 as our x. Great. Now, what it means is that we have the limits for finding the area which was shaded from 0, which was the intersection. The graph was passing through the origin, hitting its maximum at m, so implying that the x-coordinate of m is pi over 3. With that, we are going to proceed to find the area. So we are saying that the area of the shaded part is going to be the integration from 0 to pi over 3 of 3 times sine 2x plus 6 sine x dx. Great. With that, from formula 1, recall, we are going to have area being equal to minus 3 over 2 cosine 2x minus 6 cosine x from 0 to pi over 3, then substitute for the limits. Of course, starting with the upper limits, subtracting with what we would get from the lower limit. With that, we simplify our work to get to that stage. Then we further simplify so that we have a negative affecting the two terms subtracting each other. Inside we would have minus 3 over 4 plus 3 minus 15 over 2, and all this is made negative by the negative outside the brackets or parentheses. Great. So now simplifying what we have inside the parentheses, we are going to have a is equal to minus 9 over 4 minus 15 over 2. Then simplifying that, we would get our final answer as 21 over 4 square units. And we are keeping this as exact as possible. Of course, I left my answer as an improper fraction. We can actually leave it as a proper fraction without the decimals. Great. Let's move on to example 3. So with example 3, we see we have a curve over here, and the curve has got some certain points, 2 points to be precise, and intersection with the y-axis as well as the x-axis. But with what we see over here in the question, we may just consider the points that we are given here, the 2 points, one with pi over 3 and 1 over 2 as the x and y coordinate, and the other one with pi over 4 and root 2 over 2 as the other point. Great. So the diagram shows part of the graph y is equal to cosine of x. Find the exact value of integral from pi over 4 to pi over 3 cosine of x dx. B, hence show that that is equal to that. That's a bit long for me to express. But anyway, let's dive into the solution. So the first thing that we want to do is consider formula 2, where we were dealing with the cos. So that is to say that if we integrate from the lower limit to the upper limit, we are going to get sine x, and then we substitute with the limits. Remember, we substitute with the upper limit first, then subtract with what we would get when we substitute with the lower limit, so that we get to the stage where we have root 3 over 2 minus root 2 over 2. Of course, we can further simplify this to have 1/2 times root 3 minus root 2 square units. And that is the exact answer, the exact value that we are required to actually leave that answer in. And if you are confused about how we got to this, I encourage you to check out our third form video. So in this video, we cover a lot about surds and the exact values, especially when it comes to square roots and cube root. Moving on, we have obtained our A. Then we want to show that the the integral of that is equals to that. Now, I'm going to highlight one thing. The moment you see the word hence, it refers to a continuation of what you have previously done. That is to say that with the answer that you obtained in A, show that that is equal to that. So you're not working this one from scratch. You're actually taking what you have from the previous step in order to get to this final answer there, which is on the right-hand side. Great then. So we know that from part A, we can actually have A plus R. So we see from the graph now, A is a rectangle and R is that bit over there. We got half times root 3 minus root 2. That is for the area A plus R, meaning that we can actually go on to find what area R is, because we know that A is a rectangle. Great. So solving for R, we would have that. And then substituting for A. Remember, A is a rectangle, so we're going to have half, which is the length, times the width, which is pi over 3 minus pi over 4. So in that, simplifying our work, we would get to that. So R is equal to half square root of 3 minus square root of 2 minus pi over 12 square units. That is our R. Great. Also, we can see that if we then go on to find what we are given in B here, what we would have is the area B plus R. And in that case, we know our R already. So all we have is the B. So we see that B is a rectangle, and we can actually find the area of this rectangle. So taking the length of this rectangle, which is pi over 4, times the width that we would get when we subtract that. So that is to say minus 1 over 2 plus root 2 over 2 plus the R that we have. Then simplifying our work, we are going to get that. And moving on to simplify further, we get that, expanding the bracket, then grouping the like terms, we would get to that stage. And then finally, we can show that pi over 24 times 3 root 2 minus 4 plus half root 3 minus root 2 square units is what we would have on the right-hand side. Great. Congratulations if you have made it thus far. I won't leave you with a task because we're still going to continue with the trigonometric functions. I encourage you to subscribe, like, and share so that you don't miss out on our future uploads, for we still have a lot to cover on integration. Thank you so much for watching Numbers Simplified. God loves you.